Hi, I'm Tiago. I'm a senior computational biologist here at Allozymes. Basically, I started my academic career with my bachelor's in biotechnology, where I learned a lot about biology and also genetic engineering. And I did this while going to the lab and performing experimental work. After that, I received a grant to study library expression in yeast. And while doing that, I realized that the amount of data that we were analyzing was not properly managed. So that's when I decided to enroll in my master's degree in bioinformatics, so that I could really learn how to properly use data and properly manage all these knowledge that the biology was generating. During my master's, I decided to focus mainly on performing genome functional annotations and also in reconstructing genome scale metabolic models. And then I proceeded to my PhD. I got accepted to do my PhD in bioengineering systems at MIT Portugal program. I ended up switching from genome scale metabolic models and going into what I really wanted, which was protein structural engineering, computational enzyme engineering, to improve them and make them perform better. Now, it was super interesting. You can actually visualize the structure, which is awesome. It's amazing. That part really is really amazing. Yeah, I've always loved science. All science, but especially biology. Since I was a little kid, I wanted to be a scientist. I didn't know how to do that because it was much known as a role. So later I found that biology was my main focus, something that really came naturally to me. And when I found that you could combine biology with informatics, that opened a whole new world to me. That really led me to my academic career and my professional career, the world of data science and computational biology. Within biology, you can really see how much data is being generated and how much knowledge there is to explore. I really do believe that in this particular field of enzymes, they are clearly the bottleneck of industrial biotechnology. Almost all natural enzymes are not optimal to what we want to use them because they evolve naturally to the organism's conditions. You have so many combinations that it's completely impossible to explore every one of them. So by implementing these computational tools and computational biology and data science, you can really start to dig in the surface of enzyme exploration. You get a really wide universe that you can explore, from data science to computational biology. And that's what really struck me, and that's where I really wanted to focus myself, because you can start analyzing and generating all this knowledge that you can then later use it to perform new predictions or gain new insights. There are actually much more enzyme combinations to be performed that potentially are stars in the universe. So you have people in the Arctic searching for newly found organisms or unknown organisms that are more resistant to cold weather, for example. That's why you have people going scuba diving in hot areas, in volcanic areas, so that they can find these organisms that resist to very high temperatures. And this is very unpredictable. We have done this for centuries as humans, right? Exploring new worlds. But as you can imagine, these are endeavors that are very, very expensive. So it's nice to be able to do that inside the lab or with a computer. Allozymes really strikes me as a different company because of their data generating capabilities, real data generating. So basically, when you are using data science, you often you use simulations to acquire data. Those simulations are just always predictions. This is why I think Allozymes is the missing key. We at Allozymes, we have a proprietary platform that allows us to screen millions of variants almost every day. These are real enzymes that we are screening, and just check in vivo what they are producing, what's their catalytic properties, if they are valid enzymes, if they are able to fold. So all of this data that you can do with simulations can now be also done with real data. And if you combine all this data together, you can start performing machine learning models and trying to establish a data science and machine learning platform to use all of the knowledge that is being generated, trying to gain new insights into enzymes and trying to predict new enzyme variants that haven't been predicted yet or haven't been tried yet, screened yet. And you can also find ways to really explain what's happening in the enzyme that gives it that particular reaction. Yeah, I'm super excited to help Allozymes in building a future and accelerating enzyme evolution.